So we are still on module 3, Curvilinear translation, but we are now on the second lesson that is about the tangential and normal components of acceleration. So what are the applications for this topic? So sa ato ang kanang profession, we're dealing with motions of our shaft, gears, no? So the motion of our shaft as it rotates on its axis, and also the gears or other rolling bodies. So it follows a circular path, no, as shown in this figure. So in order for us to track the acceleration of our shaft as it rotates and also our gears, so we need to know these concepts, tangential and normal components of acceleration. So for our discussion for today, we are digging up the fundamental principles behind those things, no, katong ato ang pag-track sa motions ato ang mga shafts, gears, and other machine elements such as rolling bodies or rolling objects. So by the end of this lesson, usa lang ka outcome, you will be able to apply the principles of normal and tangential accelerations in solving problems related to circular motion. So we are focusing on the circular path. So the normal and tangential components of acceleration. So let's start by this first figure on the left. So from the previous lesson, we all know that the acceleration of a particle as it moves along this curved path as shown in this gray, no, is not tangent, no, is not tangent to the curve at a given point. Okay, we already know that one. And this acceleration, we can resolve this, no, we can resolve this along its component. Okay, we can resolve its component along the x-axis or along the horizontal and also along the vertical. So as shown here, we have its component along the x-axis labeled as ax, and also its component along the vertical or along the y-axis labeled as ay. So we called this resolution as the rectangular rectangular components of acceleration. So why is it called rectangular? Because we are using the x and y coordinate system. So that is why it is called rectangular. Okay, so the bottom line here is that we resolve, no, it's or we resolve the acceleration along the x and y axis. However, for our discussion for today, um, let's resolve, okay, this acceleration on a different axis, and that axis are the axis which is normal to the curve at a particular point, no, when we say normal, that is perpendicular to that curve. So this is our point A. So the normal axis is this one kanya akong drawing. So we have here an, or this is the normal acceleration. And then we want to resolve also this acceleration, no, by the way, this acceleration is the same, no, the same value, the same direction sa ato ang rectangular components, walay gi kana walay gibago, no. So aside from this normal axis, we can also resolve this acceleration, no, along an axis which is tangent to the curve at point A. So mo na siya ang iyahang tangential axis. Okay? Tangential axis. And then this one is the normal axis. Normal axis. Okay? So why is it that we still, or why is it nga required pa man, no, nga kanang ato pa siya i-resolve on a different axis. So this two axis, this new axis kaning normal axis o tangential axis, mas preferred siya if we're going to analyze, no, if we're going to analyze a rotating body, especially if mag-deal na mo og shafts pohon sa inyong higher subjects or gears. Mas dali ni siya gamiton, mas dali ni siya i-apply on other formulas, no? So, mas dali siya apply compared sa kaning rectangular components. Although na application sa rectangular components, but for rotating bodies, mostly, ang gigamit mo gud is normal axis and tangential axis or normal and tangential components of acceleration. So that is why we need to discuss this one. So again, the bottom line for this slide is that um, the normal component of the acceleration is directed perpendicular. So always perpendicular to the curve. So as shown here. And then the tangential component of acceleration labeled by AT, it is always tangent to the curve at a particular point. Okay. So how are we going to determine the value, no? Because we already know the direction of this tangential and normal acceleration, no? Very obvious. The normal acceleration is always perpendicular. The tangential is always tangent. So, ang kulang na lang is the value. So, how can we solve for its value? So, we need a formula. So, to find a formula, then we perform derivation, no? Ato i-derive. So for our derivation, let's start by this picture. So consider we have a particle that travels or that moves along a curved path as shown by this gray nga line, no? Kaning gray nga curved line. So at a particular um, location or position, so naa diri atong particle at point A, okay? Of course, it has a velocity VA, and then the velocity vector of VA is represented by this green. So it has, of course, magnitude and direction. And then it travels, no, from point A to point B. So at point B, mo na siya yung location. So, of course, it has a velocity VB. So, gituyo lang ni nga mas taas ang iyahang vector for VB. So, let's assume that this particle accelerates as it uh, moves along this curved line. So, at some point, no, um, our particle, although ni travel siya sa curve, no, we can also, I mean, usa sa mga example sa mga curved path is ang circular path. Okay, so if we're dealing with circular path, of course, that path has a radius. So we call that one as the radius of gyration, and we can represent that one by a small letter r. So this one right here. So meaning, if we extend this line, nana siya dira ay axis, no? So mo na siya ang center of curvature. And then let's consider that the the path of travel from point A to point B, tana siya ay angular displacement labeled by delta theta, no? Change in theta. So with this, in order for us to determine the components of acceleration, then we are going to isolate the velocity vectors. So, mara man itong kailangan, ang VA and VB. So, isolating first the VA. So, as shown right here, VA, kani siya. So, wala gi-change ang iyahang inclination. Gi-change lang iyahang gitas-on para mas makita na to, para mas zoom ba. But, the inclination is preserved. And then, this is our VB. So, gidraw lang siya with same initial position right here. And then, of course, the vector VA and VB is separated by this delta theta, okay, or the change or the incremental kanang kuan angle. So since we are dealing with acceleration, remember that the average acceleration is equal to the change in velocity. say that is change in velocity, we are talking about the difference, no, of two vectors. So the difference between the vector VB and VA is shown right here. So this one, delta V. Okay, but this delta V, we can also represent this one, no, or we can also resolve this one by using two other velocity vectors. But before that, ato sa i-label ang kaning mga corners sa atong nahimo nga triangle, no? Nakahimo tag triangle diri. So we have triangle OCE. And then let's assume lang for our derivation that there's a point D, no? Midway, I mean not midway but between the line segment OE, okay? And then um let's assume that the line segment OC, which is equal to VA, is equal to the line segment OD. Okay? So, ato pa siya ingon nga, this one right here is VA. So, meaning nag-project sa vector VA along the line OE. Now, if we take the difference between this one, VB, okay, take the difference between this is VB, okay? So VB minus VA is equal to the line segment DE. So we call that new velocity vector as VT, no? And this VT, this is our um, tangential velocity, okay? So this velocity is tangent to um, our curve. And then what else? So we also have a component, no? A new velocity component along line CD, okay, as shown by this red arrow. So our CD, we call that one as the normal velocity, which is at some modifications, the normal velocity approaches to kanang 90 degrees with respect to the curve. So that is why mahimo na gid na siyang normal. So when you say normal, that is um, perpendicular to the curve at a particular point. So instead of having delta V, so by this figure, instead of having delta V is equal to, again, we're talking about vectors here. So delta V is the difference between velocity vector VB minus velocity vector VA. So instead of having this one, we can also equate this change in velocity by these two new um, component vectors, no, kaning Vn and Vt. So therefore, in other sense, the change in velocity, no, this vector is also equal to the sum of the normal velocity vector plus the tangential velocity vector. Okay, and if we multiply both equations by the change in time, no? If ato siya multiply by the change in time, so multiply both sides by 1 over delta t, okay? So we can say that the change in velocity vector with respect to time, no? This is a very familiar expression. This one is the acceleration, okay? So we have Vn over delta t plus Vt over delta t. Again, still a vector. Okay, so again, this expression is the instantaneous. Okay, this is the instantaneous um, velocity. So ato lang siya, I mean, this is the instantaneous acceleration. So in order for us to to really understand this one, so ato lang siya i-change into derivative. So the derivative of the velocity vector with respect to time is equal to the derivative of the normal velocity vector with respect to time plus the derivative of the tangential velocity vector with respect to time. This expression are equal, ato na siya i-convert into instantaneous, no? So this is change and this is the change at a particular point or at a particular instant. So this one, the derivative of the velocity with respect to time, this is equivalent to the instantaneous acceleration at a particular point. So we have the acceleration vector is equal to this one. The velocity, I mean the normal velocity, the derivative of the normal velocity with respect to time is equal to the normal acceleration. So we have an plus this one is our tangential acceleration vector. So therefore, um, we have just derived the acceleration at a particular point, which is equal to the sum of the normal velocity vector plus the tangential velocity vector. So since kay mas importante man no makahibaw ta sa iyang numerical value, since ang ato ang na-generate nga equation is vector man siya, okay? So in order for us to determine the magnitude, because ang vector na siya magnitude and direction. So ato sa ikuan ay iyahang magnitude. For the magnitude, so for the magnitude of our acceleration, pahinga ni siya, mara siya naka-absolute value, that is equal to the square root lang, okay? So the square root of the normal velocity squared plus the tangential velocity squared. And how about its direction? So direction. For its direction, same lang sa katong sa statics nato nga mga forces, no? Kay mura man siya og kuan triangle. So ang head direction, use this expression tangent theta is equal to the tangential acceleration all over the normal acceleration. So always remember these formulas. Okay? So in the next slide, no, ato na po i-derive ang formula for the tangential acceleration and the normal acceleration. Kay lacking pataani. Ang ato palang diriya is nakuha na ang expression for the instantaneous acceleration in terms of the normal acceleration and the tangential acceleration. But we still don't know kung say formula for the tangential acceleration and the normal acceleration. So again, ang bottom line diriya, the instantaneous acceleration at point A is the vector sum of its normal and tangential components. So next slide, diriya, so ato i-derive ang formula for the normal acceleration and the tangential acceleration. So let's start with the easiest one, the tangential acceleration. Tangential acceleration. So our tangential acceleration, AT, is simply the derivative of the velocity, no? Derivative of the velocity at a particular position, let's say at VA. So whatever the velocity there, no? And then imo siya i divide by time. So that is now your tangential acceleration. So just use this formula. Okay. For the second one, the normal acceleration. So naa siya ay derivation nga mahitabo normal acceleration. So for the normal acceleration, let's consider this triangle OCD. No? So in the triangle OCD, so we all know that line OC is equal to VA, and then line OD is equal also to VA. Now at a small increment, no, of theta, or at a very small angle, no, actually mo approach ang angle OCD by 90 degrees. So mahimo ni siya diri og 90 degrees. And with that information, we can say that the the length of CD, or that is equal to the vector Vn, no, is just equal to, so mahimo na siya og, actually if ato na siya utrohon, no, utrohon og drawing. So let's draw this again para na siya. So this is 90 degrees. So this is our Vn, this is our Va, and this is our very small angle theta, or let's call this d theta. So with this expression, using your trigonometry, we can say that a small value a value of a bn, so ato lang siya ipang ano, change, no, kay very small lang ba, kay since we're dealing with small angles, then automatically these are small values of our normal velocity and also to our absolute velocity at point A. So by using your trigonometric identities, specifically the sine identity, no, kay opposite man siya, so we have uh, derivative of the normal velocity is equal to the derivative of the velocity at point A times the sine of theta. However, at a very small angle, actually ang atong sine of theta, no, approaches to the small increment of theta. So therefore, derivative of the normal velocity is equal to our derivative of our velocity at point A. However, in most cases, that is equal to a constant value, no, kay given ang velocity at point A. So that's equal to VA, and then derivative of the angle theta. Now, sunod na tukhaon ani is ang iya distance, no, or ang path of travel niya. So consider this arc, no, this arc AB. Now at a very small angle, no, kung gamay kini siyang angle, what happens is if we try to draw it here, hitabuan na gamay kini siya, no. Di na ako pagamin kay di niyo makitaan. So for the purpose of illustration, ingani lang. So at a very small angle, no, mahitabuan na is ang arc mo approach siya by a straight line or a chord. So therefore we can also say that I mean the formula for arc length, don't forget that one. The formula for arc length is S is equals to R theta. Okay, by this information, if we apply derivative, meaning for a small value of the arc, mo approach siya by a chord by a straight line by this one. So we have a small value of the arc, no, or mo approach siya og chord is equal to the radius, no, or which is equal to the radius of curvature. So again, R, para di makalimutan, this is the radius of curvature. Radius of curvature. So again, don't forget this formula sa inyong trigo, S equals to R theta. So at a very small angle, of course, mo vary po ang iyahang arc length. So the derivative of the arc length is equal to the radius times the small increment of theta. Now, we are going to apply, or we are going to substitute these two equations. We have first equation, we have second equation. We're going to use this one at substitute ngadto sa ato ang general formula for the normal acceleration. So remember that our normal acceleration is defined as the change in the normal velocity with respect to time. Okay, and we know that from equation 1, the change in the normal velocity is equal to the velocity at point A times the change in theta. So VA, change in theta, all over d theta. So we already know that d theta is equal to ds over r. So we have VA ds over r dt. Now, our ds over dt, no, this one right here, actually, if we're going back to our previous lesson, no, but ang ato ang ds over dt, that is simply equal to the velocity at point A. So nga naman sir, although ang S na to diri is pasabutan nila arc length, however at a very small angle, actually di na siya ang arc length, no, but ang chord na lang. So remember sa previous lesson, we denote this one as the displacement and we label this as delta S. So mara siya pasabutan ning ds. Okay? So not the arc length but the chord at a very small values of our angle theta. Okay, so ds over dt is simply VA. So therefore, the final formula for our normal acceleration is we have VA times another VA over R, or that is simply equal to the VA square all over R. So don't forget this formula for the normal acceleration. Okay, so without the derivative, actually, ang tangential acceleration is just simply equal to the velocity over time, no? Whereas, or this is VA over time. Whereas for the normal acceleration, that is the square of our velocity at a particular kind of point. So for our derivation, that is at point A, divide by the radius of curvature. So don't forget this one. Okay, and then how are we going to solve for VA? So in some problems, no, ang normal gid anin natong makuha is that mostly if we have a rotating body now at a radius r, and then a particle nag-rotate, of course we're given with the angular velocity, no, sa inyong trigonometry. So angular velocity w. So to solve for the velocity at that point, let's say this is point A. So if this is VA, so don't forget sa inyong nakuan, naibawaan sa trigo. So that is the radius times the angular speed. Okay, and by this information pwede na nimo i-substitute sa imong tangential as well as sa imong normal acceleration. Okay, so that you can solve for the absolute acceleration of your particle, no, as it moves along this curved path. Now, what happens if ang ato ang velocity is constant? So, ang mahitabuan is that if the velocity is constant, walay change. So, therefore, ang mo-exist lang kay, sa may mo-exist, only the normal acceleration. Because sa iya formula, walay nakabutang da nga change, no? Or walay nakabutang da nga derivative. Just simply the magnitude of the velocity a square all over r. Unlike tangential, no? As a tangential, sorry, I forgot to put another increment. So, unlike tangential acceleration, na siya incremental change. So, that is mo highlight na nga derivative of the velocity. So, if there is no change, so therefore, your tangential acceleration is 0. So, even if ang imuhang object kay ni tuyok no on a circular path, dili ka kaingon ha nga sir wala na siya acceleration because constant iyang pagtuyok. Naa gyapon siya acceleration. Unsa man nga klase sa acceleration ang naa gyapon niya? That is only the normal acceleration. Okay, by looking at the formula, we can solve for the normal acceleration. Walang siya tangential acceleration. So always remember that even if constant ang pagtuyok sa usa ka cylinder or imong gears, constant ang pagtuyok, you still have your normal acceleration, but you don't have your tangential acceleration. However, if mukalit lag kusog ang tuyok, so naa na kadira ay tangential acceleration. Okay? So, naay question so far? Hello class, are you still following?
Wala na ko, sir.
Wala ra? So, we are going to use this concept, especially kaning formulas for tangential acceleration and also the normal acceleration in solving problems about circular motion. No? So, let's have our first problem. So, point A in the figure below, so this is the figure, moves, this is in, so this in a circular path. So, we have a circular path shown by this gray outline of 20 feet radius. So this is our radius 20 feet. So that its arc or its arc length from an initial position B is given by the relation S is equals to 60 cube minus 40. So equation ay iyahang value for the S. So this is the S. This is not a chord but an arc length. So ayaw kalimti. This is 60 cube minus 40. So the initial position of our particle is gikan siya ni B daw. Nituyok siya in a circular path at a point A. So na siya angular displacement labeled by this one, theta. Okay. So again, where S is in feet and T is in seconds. So determine the tangential and normal components of acceleration of the point for the instant when T equals 2 seconds. So at point A, ang time na diri ano, sa kaning final position, the time here is 2 seconds. Okay? So the second requirement is find also the resultant acceleration in magnitude and its inclination with respect to the x-axis. So this is our x-axis. Understood? If this is our tangential and normal accelerations, so naadri ang iyahang kanang absolute or resultant acceleration. So pasabot anang inclination is with respect to the x-axis. So kanis siya. Ato siya labeled as a phi lang. Okay? So una, we're going to determine the tangential and normal components of acceleration. So let's start with the tangential lang, okay? Tangential acceleration. Okay? Ay symbol kay AT. Okay. So sa ato ang previous na slide, the formula for the tangential acceleration is the derivative of the velocity with respect to time. Or in other words, that is in terms of displacement, no? So i-recall to, or this is equal to the second derivative. So that is d square, let's say s over dt square. Okay, so don't get confused sa katong ato ang gi-represent sa previous nga x, no? Kay diri we're talking about curvilinear motion. So we're talking about the displacement along the curve. Okay, so that is why ds lang. ds square over dt square, or the second derivative of the function s with respect to time. So luckily we are given with the function s that is equal to 60 cube minus 40. So we take kanang two successive derivatives, no? Kanin siya. So let's have our first derivative. Let's say first derivative of 60 cube minus 40 with respect to time. So first derivative of this one, 60 cube. So power rule, 6 times 3, 8, 10, t square minus 4. So, mao pa lang ni iyahang first derivative. For the second derivative, so d square s over dt is equal to the derivative of this 18t square minus 4 with respect to time. So that is d square s over dt, that's equal to 18 times 2, that is 36. So we have 36 t. Okay, t na lang tira. And then after that, so mo naman siya ato ang equation, no, for our tangential acceleration. So since given mata na at t equals 2 seconds. So at t equals 2 seconds, so our tangential acceleration is equal to 36 times 2. So that is equal to 72, no? 12, 6, so 7. So that's equal to 72. Don't forget the unit, feet per second square. So this is our tangential acceleration. For the second requirement, to isolve ang iyahang normal acceleration. So normal acceleration labeled as an. For the normal acceleration, that is an is equal to the square of the velocity, no? Square of the velocity. So VA square all over all over r. Okay, so I mean, okay, yes, diri sa VA because at point A naman ta. Now, unsa man pag-solve sa VA? So to solve for the VA, remember that the velocity or the instantaneous velocity, since we're talking about a particular point that is at point A, so that is equal to the derivative of the displacement with respect to time, or simply the first derivative of this one. Na naman tayo first derivative, that is 18t squared minus 4. So that is 18t squared minus 4. So at t equals 2 second, we can solve for the velocity. That is 18 times 2 square minus 4. Okay, so palaban tagal kayo. We have 18 times 2 square minus 4. So the answer is 68. So we have 68 feet per second. Now we're going to use this information to solve for the normal acceleration. So therefore our normal acceleration is 68 square all over the radius is 20 feet. So divide by 20. So our final answer for our normal acceleration, we have 68 square over 20. That is 231.2. So we have 231.2. This is feet per second square. So this is our normal acceleration. So proceed to the next slide for the third requirement, that is the resultant acceleration. So resultant acceleration. Now we're talking about the A. So first is the magnitude. We already know the magnitude, no? Its magnitude is this one. So the square root of the sum of the squares of the normal acceleration and the tangential acceleration. So atong normal acceleration, nakuha ta ato. So that is 231.2. So 231.2 square plus the tangential 72. So plus 72 square. So therefore, the magnitude of our resultant acceleration, so 231.2 square plus 72 square, so 242.15. 242.15, this is feet per second square. So this is the magnitude of our resultant acceleration. How about its direction? So 3.2, the direction. But ang pangita di is the inclination with respect to the x-axis. Okay, inclination. Now if we draw this one, no, ato na siya i-drawing. So para ni siya nitabaan ni this is our A, then this is our normal component of acceleration, and then of course this is our kuan kani siya, sorry, at tara ni siya i-draw pa ana. So this is our AN, I mean AT tangential kani siya. So the angle between A and AT, no, kani siya, the angle between AN and A, this is our theta ba to sa ato ang formula sa balikon. Okay, we're using theta here, but sa ato a problem di na ta magamit og theta kay na may theta diri so we're going to use gamma. Okay, so ang gamma na natay formula na, no? Because this is 90 degrees. Now para ato ni wag tangon si 80, no, focus lang ta aning acceleration absolute, and then ang line sa normal acceleration and the x-axis. This is our x-axis. So, ang angle sa normal acceleration and the x-axis kani diri ang apart. This is theta. Again, this is phi. And then, mo na siya to ang, this is gamma. And then, this is our phi. Okay? Ang gipangitaan ni is ang phi. Okay? So, how can we solve for phi? Remember, this one is, kani siyang angle diri, this is 180 minus theta. So, to solve for phi, we have phi is equals to 180 no sa inyong trigonometry, wherein if i-sum up nimo ang triangle sa triangle, ang result kay 180. So i-subtract naman lang nato no to solve for phi. So 180 minus gamma minus 180 minus theta. So dapat ato sa pangitaon ang gamma and also the theta. So let's start with the gamma. So gamma is equal to the arctan, the arctangent of the tangential acceleration all over the normal acceleration. So this is equal to the arctangent of our tangential acceleration is 72 divided by 231.2. Sorry, this is 231.2. So our gamma is equal to, so this one we have shift tangent, tapos this is 72 over 231.2. So the result is 17.3, approximately 17.3 degrees. Okay, so next is we're going to solve for theta. So for theta, no, we know this equation, S is equals to R theta. So therefore our theta is just the ratio of the arc length divided by R. So our arc length is represented by this function 60 cubed minus 40. So at t equals 2 seconds, so we know that 60 cubed minus 40 divided by R is equal to 6 times 2 cubed minus 4 times 2 divided by the radius of 20 feet. So therefore our theta, again, ang answer ay niya class, di na siya angle ha, kay mga distances man na dira ano. So ang result ana kay is in radian, not an angle. Oh, not in degrees. So kani this is cube minus 4 times 2, then divide by 20 ang radius. So ang theta nato is 2 radians. So be careful. Now if ato na siya i-apply sa atong formula to solve for phi, dapat na-convert na siya into degrees. So remember that 2 pi radians, or ato lang i-delete no, kay ang pi is equal to 180 man. So use na lang taog pi. So, this is pi and this is 180, no? So that is equal to 114.60, no? Take one na. So that is 2 times 180 over shift pi. So 114.6. That is equal to 114.6 degrees. So therefore our phi is equal to 180 minus 17.3 minus 180 minus 114.6. Okay, so our phi is equal to, so we have 180 minus 17.3 minus 180 minus 114.6. So the result is 97.3. So we have 97.3 degrees. So this is the angle of inclination of our resultant acceleration with respect to the x-axis. Okay, naipangutana so far? Naipangutana? Wala ra? Okay, so proceed ta sa last nga problem. So a particle moves in such a manner that the acceleration along the x-axis is negative 6 feet per second square. If its initial velocity is 100 feet per second directed at a slope of 4 to 3 as shown below, so this is the figure. So compute daw the radius of curvature of the path 2 seconds later. So naatay duha ka kanang position sa atong particle that is traveling on this curved path as shown by this red line. So from the initial position point A to the final position point B. Now at point A, it has an initial velocity v naught equals 100 feet per second. So yung angle represented by this triangle, no? So 4, 3. So automatic, this is an Egyptian triangle. So if we have here 4, this is 3, automatic, this is 5, and this is our angle. No? This is our angle. Ito siya i-denote as gamma lang. So next is that after 2 seconds, so the position of our particle is at point P. At point B, its velocity is represented by this velocity vector shown in red, and ato siya labeled as V. So always remember that its velocity along the curved path is always tangent to the kanang curve, no? So di na siya pwede at any angle. Now, ang iyang velocity, no, we can also resolve its velocity along the x-axis. So we already done this one, and also along the y-axis. Okay. So since ang given nga mga accelerations is along the x and y components, no? Na madria. So ato na siya i-map pud sa ato ang figure. So that is why since our ax, the value of our acceleration along the x component is negative, so ang iyahang direction is towards the left. So as represented by this one, ax. And the same way, why is it nga ang ay kay kanang paubos? Of course, very obvious, since ato ang velocity, no, y, the component velocity y is pa upwards. So ang reaction sa ato acceleration ana is pa downward. Remember sa ato ang discussion regarding projectile motion or by using the D'Alembert's principle. Okay, so okay, I think I forgot why is it nga ang ay kay below? It's because I forgot to put the value for ay, no? So I just write here. So our ay naman sa libro, no, kang singer, ay is equals to negative 30 feet per second square. So negative siya, obviously paubos gid siya. So that is why paubos. Now ang ipangita is the radius of curvature. So required is the r, no? So solution. Now sa mga previous nga to mga na-derive, no? Ang atong way lang to solve for r is by using the normal acceleration, no? Because the formula for the normal acceleration contains the velocity at point B. So we're talking about the velocity na at point B because that is our location of interest or our point of interest na mandira ang particle after 2 seconds. So VB square divide by r. So naatay r diri if we know the exact value, or if we know the value of our normal acceleration as well as the velocity at point B, then we can solve for the radius of curvature. So let's start with solving for the velocity at point B. So how can we solve for the velocity at point B? So use our knowledge, no? Use yung knowledge sa previous nga lesson katong sa projectile motion. So remember that our velocity, no? Velocity B is just equal to, no, the square root of its components. So that is velocity B at x square plus the velocity B along y square. Okay, so how are we going to solve for the velocity uh, B along the x and also along the y? So let's start with the velocity B along the x. So use the kinematic equation wherein, since we have an initial position A, final position B, so unlike projectile, no, ang nahitabo sa component velocity along x, it has an acceleration, unlike sa ato ang gi-assume sa previous lesson that the acceleration along x is zero because we neglect air resistance. However, in this problem, given man iya acceleration sa x, so therefore magamit ato ang kinematic equation nga final velocity is equal to the initial velocity, no, that is v naught x, and then plus 80. So plus the acceleration x times the time, and luckily we are given with time that is equal to 2 seconds. So therefore the velocity b along x is equal to the initial velocity, and that is cosine of gamma, no, from this triangle, minus, so minus siya since the given acceleration is negative, so minus 6 times 2 seconds. So our initial velocity is 100 feet per second. Our cosine theta by this triangle, that is adjacent over hypotenuse, so that is times 3/5 minus 6 times 2. So therefore our velocity at point B along the x-axis is 100 times 3/5 minus 12. So that is equal to 48 feet per second. Now for our VBY, no? So we have VBY still equal to VOY plus AYT. So that is equal to VO sine gamma. And then our acceleration along y is negative gihapon, so minus 30 times 2. So that is 100. And then our sine gamma is opposite of hypotenuse, so 4/5 na siya. So 4/5 minus 30 times 2. So our velocity at point B, so we have 100 times 4/5. This is 60. Okay, so the result is 20. This is 20 feet per second. So therefore our BB right here is square root of 48 square plus 20 square. Okay, so we have square root of 48 square plus 20 square. So the answer is 52. 52 feet per second. So this is the velocity of a particle at point B. The next is we are going to determine the normal, no, the normal acceleration at point B. So diri lang sa next nga slide. So solve for the normal acceleration at B, that is a n. Okay, so since given man ta ang ato ang ay and also our ax, again ha, ang ato ang normal acceleration is directed perpendicular to our curve at point B. So this is our point B, remember. Dili na to ibutang dira dili lang dapit. So this is our point B. So to solve for the normal acceleration, diri sa ubos, no? Ubos man na siya directed. This is our AN. Now, we need to resolve each acceleration, each given accelerations along this axis N. Okay? No? Ato na po siya nabuhat no sa una. So, if ato na siya i-project, okay? So, makaibaw na ta, no? Makaibaw ta sa iyang value along this normal line. Now, problema ani walay mga angles. So kani pod ato ni project dira. So na siya component along this one. So we don't know the angle diri ato lay theta, and also mas better diri nga part. So mo na siya iyang atohang kuhaon, pero pataas iyang direction na. So what ta kay baon sa angle ani? But the angle theta here is equal to the angle of the velocity right here. No, ato na i-drawing. So therefore, ato sa pangitaon si theta. So in solving for theta, so use the tangent identity. So tangent theta is equal to Vy over Vx. So therefore, theta is just the arctangent of velocity y over velocity x. Ato na nakuha sa previous na slide. So kani velocity Vby, that is 20 over 48. This is Vby, Vbx. So Vby 20 over 48. So therefore, our theta, arctangent 20 over 48. So our tangent theta is equal to 22.62. So 22.62 degrees. Now to solve for the normal acceleration, so AN is equal to the component acceleration of our acceleration AX. Now that is pa-upward man siya, no? Pa-upward siya with respect to the normal axis. So we have AX. This is cosine. So this is AX cosine theta. Sorry, this is sine day. AX, this is sine. AX sine of theta. Why is it na sine man, sir? So ipaton siya extract ang triangle, may tabaan ni inaana siya. No, this is our AX, this is our theta. This is our kanang kuan mo na siya atong gipangita, no? That is AX at the normal axis. So sine siya. So AX sine theta. Tapos minus. So why is it minus man? Because ang direction ni AY is paubos. So i-subtract. No, i-subtract siya. So therefore ang AY nato is kuan kanang if ato na po siya i-extract ng triangle, paana siya. Okay, so this one is theta. This is our AY and this is siya, this is our AYN, no? So therefore, again, this is our AXN, then minus this is AY cosine of theta. This is our AYN. Okay? Substituting uh, kanang values, no? So our AX negative. So we have negative 6. Tapos sine of 22.62 minus our AY is negative. So minus negative 30. I forgot. Kutang ta AY is negative 30 feet per second square. So negative 30 times cosine of 22.62. So our normal acceleration is negative 6 sine of the answer, no, na kuan mo to siya na na store. So minus negative, so plus 30 cosine of answer. So the answer is 25.38. 25.38. This is feet per second square. Okay. So next ani, solve for r. Solve for r. So therefore our r is equal to, so that is the velocity of b squared divided by the normal acceleration. So our velocity at b is 52. So 52 squared divided by 25.38. Okay. So by using our cycle, 52 square divided by 25.38, it will result to 106.54. 106.54. 106.54. This is feet. So therefore, this is the value of our radius of curvature. Any question so far? Before I entertain any question, ako sana i-end, no, ang record.